This is Group 3's final project presentation of Tempest Tracker. This is part of SDEV265 with Professor Ray Storr. These are our team members. There's only 3 of us, and I'll get into it. So before I continue going on to the next page here, I'm going to do a brief demonstration of the executable that we've developed. So it's called Tempest Tracker. If I go ahead and open this, it's running on Python, and here is the input box. So the idea behind this is that people can input a location, so I'm going to put my location in, and get pretty much real-time data back. So we got the temperature, location, humidity, condition, and wind speed. These 2 things can be switched. This can be switched between imperial and metric, as you can see. Wind speed converted. I've added it here for demonstration purposes. For temperature, you can switch between Celsius and Fahrenheit, and you can see here it's converted. And if I go ahead and do a couple of fake inputs, it will give me an error message. So here we got the first error message, input not recognized by the API, 404 error. The other ones that we have is if you don't input anything, it says to do it again, and if you input just spaces or fake characters. Not a fan of spaces. So that's pretty much all the functionality behind our application. It's very simple and manageable. So I'm going to close this down and get back to the slideshow. So for the first document that we created during development, we did the requirements document, which says a couple of key points that we wanted to definitely have, or in other words, were required for our final project. So the first one was to easily switch between different locations. This is a pretty user-friendly interface, and it's pretty obvious that we're supposed to type the location here. However, there is not the most advanced input verification in terms of like spelling correction or checking if the city exists, but I'll get into that later. So the next thing is view the weather information in a clear and intuitive interface. As you saw in the demonstration, pretty clear. There's not a whole lot of stuff to get in the way. The next thing was users can select preferred units. So this one we have for temperature and wind speed, not for some of the other fields, but those ones only have 1 unit, so you don't really need to switch. So the app should also provide clear error messages. As you saw, we had a couple of different error messages in case something goes wrong with input. So on to the next section. We did a feasibility study, and here's the summary of that. So we asked, was the project technically feasible? And this one is pretty easy. Yeah, it's technically feasible. People have done weather apps before. Legally feasible, again, the API that we used was open source, and people watch the news all the time to get the weather, so shouldn't be a problem. Feasible within a reasonable time frame. So this one we were a little worried about, or at least I was, because there were 3 people on the team, and we weren't really sure how things would go in the long run because none of us had really worked with a team like that before. But everything worked out, and we kept the actual project scope to a pretty low standard because we didn't want to overextend ourselves, and I think we did a good job there. Economically feasible, that was just to kind of pretend that we're a real software team in a company, but we're not, so we're not actually spending money. So the other questions that we asked in the feasibility study were, is the project possible with our currently available technologies and without changing our budget? This again was just part of pretending, but the available technologies was, what do the team members know individually? So we had some team members that already knew how to do certain things, and we kind of took that into consideration when planning on how we would build the software. So for example, we had one team member that knew pretty extensively about how to use tkinter and actually a custom tkinter library. So that came in really handy. So can the system be integrated with other systems? Yeah, so I mean, we don't have like a custom API or anything, but we do have a very modular code base, and we put everything into classes, and all of the data is stored in like variables in those classes and named very well. So if we were to make another system, it wouldn't be too hard to integrate it. Will we be able to deploy to multiple platforms? Yeah, we could if we had somebody with a Mac that would be able to build the program. We built the program with PyInstaller, I believe, and we only did it for Windows right now, but we could definitely build to other platforms if we wanted. So next, the project plan summary. In the project plan, we kind of went over different team roles, and we also did a work breakdown, and you can see here's some screenshots of each. So, we start with planning, weather, location, making everything into classes, and then UI integration with the API, stuff like that. This is just more of the project plan summary. We went over hardware and software requirements, and you can see all of those here. This is the different modules that we thought we would use at the time. For the process flow diagram, it's kind of a flow chart of how the program works. So user opens the weather application, app displays the GUI, and it goes through all the different user input possibilities. This was part of the project plan summary. The last part was we had a Gantt chart and communication channels. So we followed this pretty good, but some stuff gets shifted around, and we tried to update it once we were finished with the project to more accurately portray what the development really looked like. Communication channels, we use Discord mostly. These other things were for live collaboration and just tools to make documents. This was for the Gantt chart. And Zoom, everybody used Zoom. Risk assessment. So in the risk assessment document, we kind of talked about schedule risks, performance risks, operational risks, all of the risks that were outlined in that document's or that assignment's rubric. And for the most part, there wasn't really a whole lot of risks. The thing we were most worried about, again, was communication, because we had been on teams in the past where some members just didn't end up, or at least I had, where some members just didn't end up communicating at all. But that didn't end up being a huge problem, so I was pretty proud of that. Also, the scope creep risk, that could have been an issue, but I think we almost underscaled. So we didn't make a very huge project. It was pretty simple and basic, but I think that turned out for the best, because then we were able to focus more on documentation. Design document, here's some just pictures that we had on the design document. So we had a sequence diagram, the architecture design diagram. We didn't end up using any kind of data storage between sessions, so this part is inaccurate, but the rest is pretty accurate. We used the MVC model. Here's the UML diagram. We followed this pretty well. Nothing really changed here. And the interface design. So as you can see, it actually turned out pretty similar. We got different images, but for the most part, everything's about the same. Functionally, it is the same. User documentation. So installation instructions can be found in the GitHub repository under the README, and also in one of our assignments that we turned in. But that's only available to our professor, so if anyone else wants to see the installation instructions, it's on the README. System requirements, this is something else we went over in the user documentation. We went over the installation steps to get the repo on a local workspace. So that's separate from installation instructions of the executable here. Required libraries. Yeah, so this can be found in the requirements.txt, but also can be found here on the project plan. We're using tkin to request for the API. So yeah, that's it for the user documentation. What tools did we use? We used VS Code. All of us did. We used GitHub, obviously, and Git for version control. The programming language was Python, and we used custom tkin, which was a library that kind of extended the original tkin capabilities. Next, these are, again, just kind of a recap of all the tools that I've already talked about from the project plan. And then here's some demo screenshots. So here we got a screenshot of the actual application, which I've showed, and then just some screenshots showing that we can display the information and get validation on our input. All right, so this is the summary. So I'm going to go ahead and read this. The purpose of the project was to create a user-friendly weather application called Tempest. It was developed using Python and its robust graphical libraries. The Tempest Tracker application was able to successfully install, run, and retrieve data, and present it in a user-friendly manner. The application has built-in input, error handling, and exception report. So there's that. That's kind of what we typed in our documents. I kind of messed it up at the end there, but that's okay. Future enhancements. All right, so a couple of things that we'd like to add is one, more weather information. So if you look here, when I type in a location, this is most of the weather information that we can get from the API. So a lot of this just isn't displayed on our program. Things like weather description instead of just condition, so clear sky. We can also get the exact longitude and latitude of the location. We can get kind of the visibility rating. We can get more information on clouds. We can get the country that it pulled from. All of this data just we don't really display. So there's still a couple of things we could do, like time zone. I'm going to go ahead and close these. Background picture. So if it says clear, we should change the background picture to kind of be a clear sky. Or if it says cloudy, we kind of cloudy. File menu ribbon bar. This is something else that we want to add. So up here on file, we could kind of hit file and close, or file and save, in a similar way to how VS Code has this ribbon bar here. Autofill search location. So I mentioned this at the beginning, and I said that I would go over it later. So right now, if I type in South Bend and hit search, I'm pretty confident that this is going to get my location, but I'm not sure, so there could be another South Bend. We never really implemented a drop down here that would show up all the South Bends, and then we could kind of select which one we want. So South Bend, Indiana, South Bend, wherever another one. This isn't really a problem with this particular city because it's not a super generic name, but say somewhere like Houston. How do we know this is the Houston from Texas? You know, so just an example. And then question and answers. So if anyone has questions, or if the teacher watching this, if you have questions, you can message us through our IB Tech emails, or just talk to us in class. I don't know if any students are going to watch this, but yeah, just let us know. Thanks.